Hi boys, so we're going to look at the last two examples on the sheet that I gave you in the last lesson. I did tell you to look at the solutions in the textbook to see if they match what you wrote down, but if you had any queries and didn't understand something, then watch the video. You will learn something even if you've done these questions already. Now, this says for the standard normal distribution. Now you've got to be aware that as soon as I say standard normal distribution, they're talking about z-scores. So anything that we work out here will be to do with z-scores and the z-score distribution table. All right, so let me just make this two medians here. All right, so we're going to find the median. All right, now remember, for my standard normal distribution, which goes something like this. See, my drawing on this is not so easy to get straight lines, but anyway, I'll do my best. Now we know that the median and the mean are equal. So if I'm finding the median, then I'm also finding the mean. Now, on a z distribution or a standard distribution, we set the z-score there to be 0 for the median and also the mean. And we know that for a normal distribution, 50% of the data is to the left of the distribution. Okay, so what you're trying to find here is the probability that z less than 0, right? Because the median and the mean are equal, so that's why we've got the 0 there, is equal to 50%, which is also 0.5. Okay, so you've answered the question here. The median is 0 for the standard distribution. Okay, so you've got to be aware though that this median is just for the z distribution. If you wanted to find the median of the actual data, in other words, the x distribution, you'd have to use your formula for z-scores to work that out. Let's just write the answer down. So the median for the standard or z distribution is 0. Okay, I think I've just write that a little bit to the right there. I've spaced it a bit better. Okay, so is 0. Okay, so the median for the standard distribution is 0. Now, if you wanted to work out the median for the x distribution, because remember this here is the z distribution for z-scores. So you know that the formula for calculating a z-score is the actual score minus the mean divided by standard deviation. Okay, so we don't have enough data to work out the median for the x distribution, but if you did, if they gave you the standard deviation here and also the mean of the x distribution, you could work out the x score, which corresponds to the median for the x distribution. So I'll basically go 0 is equal to x. That's what I'm trying to find. I would have to give you the mean in the question, but also have to give you what the standard deviation is. If they give you those two things, you can work out the x score, which corresponds to a median of 0 in the z distribution. Okay, so the median for this question is 0, but it's 0 for the standard distribution. You've got to be aware of that, right? This is all to do with the standard distribution. Now, for the lower quartile, right, now, remember the lower quartile? Lower quartile is Q1, okay? We know that for Q1, 25% of the data is below Q1. So what you want to find then is the probability that the Z-score is less than to a particular number, we'll call it M, is equal to, and we could write 25%, but we're going to write down 0.25 instead because your Z distribution table has decimals, not percentages, okay? So 25% of the data lies below Q1, so that's where the 0.25 comes from. We want to know what number in the Z distribution table corresponds to this. So we're trying to find this number here from the table. So let's go to the table itself. Okay, here it is. And we're going to, well, how do I know to go to the negative? Well, 25% of the data will be to the left of the median, won't it? So if I come down here, got to keep scrolling. Now, if you look at negative 0.6, and that corresponds to the second decimal place of 7, so negative 0.67, I've highlighted it here. You can see 0.2514 is not 0.25 exactly, but it's the closest to 0.25 in the table. So we're going to use this as our value, okay? So the number that I'm looking for the Z-score, so the Z-score will be negative 0.67. So let's just write that down. So the probability that the Z-score is less than negative 0.67 is approximately 0.251424 decimal places, okay? Now, we didn't get, if you look at these two numbers here, here's the comparison. I didn't get exactly 0.25 from the table, so the best I can do is this, all right? So what I'm going to say there, therefore, lower quartile, or Q1, lower quartile, I'm going to put down approximately, because it is approximate, it's approximately negative 0.67. Okay, it's approximate because we didn't get exactly 0.25 in the table, we got 0.2514. So this is the approximate value for the lower quartile. I'm going to make sure I make this statement for the standard distribution. Okay, standard normal distribution. I'll abbreviate DIST. Okay, so if you wanted to find the lower quartile for the X distribution, just as I said over here, right, you'd have to use that formula to work out what X score corresponds to this result here. Okay, so there's your Z score there. You'd put your Z score of negative 0.67 where the 0 is in this case. They have to give you the mean, they have to give you the standard deviation, and then you could work out the X score, which corresponds to this particular Z score, okay? And that X score would be your actual lower quartile, right? So just be aware that this lower quartile is for the standard normal distribution. Now, the other interesting thing is, how do I know that that was going to be negative? Well, because I know that Q1 has 25% of the data below it. If I was to just do a little sketch of a normal distribution down here, and there's my normal distribution. Now I know that if I put a line down the middle for the mean, 50% of the data is on the right, 50% is on the left. So if I'm looking at the where 25% of the data is below, oops, so it's this, I'm going to just estimate, let's just say that's 25% of the data. So I know that because this has got a Z-score of 0, right, and I want to know what Z-score corresponds to here, and it's to the left of 0, I know that the z-score is going to be negative. Okay, so let's have a look at the next one, upper quartile. Now the upper quartile is Q3, of course, and for Q3, right, we know that 75% of the data is below Q3. So let's try working out again. We want to find the probability that the z-score is less than a particular number, which we're trying to find, and probability that is equal to 0.75, because we know 75% is 0.75. Okay, so I want to find the number in the table which will give me 0.75. So let's go back to the table here. And now the other thing is I should have some idea of where it'll be. So if I did a little sketch here of my normal distribution, there it is. I know that the 50% mark, or the 0.5 mark, sorry, that's not right. Well, yeah, 50% mark is in the middle, but let me roll that. That's got a z-score of 0 there, as we know. So let me put that in there. Okay, so z is equal to 0 here. Okay, I've got a z-score of 0. But I know 50% of the data lies to the left and to the right. So 75% of the data will be maybe roughly here. Okay, so I want to find the z-score, which corresponds to this number here, right? Because that will be my 75% of the data. This is just a rough sketch. So I'm looking for a z-score which is bigger than 0. So I'm looking for a positive z-score. So let's have a look. So go back to the positive area. Now, if I look at 0.25, now I'm looking for 0.75 here, aren't I? 0.75. So not there. Here is the one I want. So here's the 0.75. In fact, it's not 0.75, but it's closest to 0.75. If I look at 0.7517, that's not as close to 0.75 as this one here. Okay, so that means I'm looking for a z-score of 0.67. Okay, so this is the number in the table closest to 0.75. So that's going to give me 0.67, right, for my median. So let's have a look. Coming back to here. So I'll just scroll up a little bit. All right, so it's going to give me, this is what I can write down, the probability that Z is less than 0.67, all right, is equal to, well, I guess you could say approximately equal to, 0.7486. All right, so that means we can write down, well, so this is your upper quartile for the standard distribution. So therefore, we can say that Q3 is approximately 0.67, right, for the standard normal distribution. Okay, so don't forget, so the median that we're finding is for the Z distribution. So this number here, if you've got answer, is a z-score. All right, now let's look at the next one, which is the 84th percentile. Let's try that one. All right, so I want to find the probability that Z less than to M, where M is my 84th percentile in this case, The 84th percentile is 84%, which is just 0.84. Okay, so if you did a rough sketch of that, here's my normal distribution. Now we know that the z-score of 0 here corresponds to the number which divides the data into half. So 50% to the left, 50% to the right. So 84% might be somewhere over here. Okay, I want to find this value here, which represents 84%. So 84%. So 84% of the data, right, is below this value here. Okay, so let's have a look. We want to find in the table the z-score, which corresponds to this number here. So let's go to the table again. All right, we want to try and find 0.84. So if you come across here to 0.9, and you can see 0.8389 is actually the closest to the 0.84 that we want. It's closer than that, and it's also closer than 0.8413. So this is the closest we're going to get. So 0.8389 is what we're looking at, and our z-score, which corresponds to that, is 0.99. Okay, so let's write that down. The probability that z is less than 0.99 is equal to, well, approximately equal to really, 0.8389. Okay, so that means we can write our answer as follows. That the 84th percentile, so 84th percentile, I'm going to put down is approximately, because it's not exactly 0.84, is it? It's approximately 0.99. And again, I'm going to say that's for the standard normal distribution. All right, so your 84th percentile is a z-score, right? Because we're looking at the standard normal distribution, right? You could find the equivalent 84th percentile for the x distribution, again, if you use your z-score formula. Okay. Now let's have a look at the next one, the 6th decile. Now the 6th decile is the 60th percentile. Okay, so let's be aware of that. That is the 60th percentile, because we know that a decile is 10%. Okay, so you want to find the probability that z less than m is equal to, well, 60% is just 0.6. Okay, so we want to find the number on the z distribution axis, or the horizontal axis, which where 60% of the data is below that. Okay, so we want to go to the table, find the number in the table, which is 0.6, and see which z-score corresponds to that. Okay, so let's go back to our table. So our table is here, and if you look at 0.25 here. Now, 0.25 has 0.5987. Now, I want it to be 0.6, but I can't really get much closer than this. This is not as close, neither is this. So 0.5987 is the best I can do. I'll come back to my answer then. I'm going to write down probability that z is less than 2, and the z-score which corresponded to this was 0.25, right, is equal to 0.5987. So, therefore, I'm going to say the 6th decile, or the 60th percentile, 6th decile is approximately 0.5987. Right? Now, because, oh, sorry, that's my mistake there. That should be 0.25. Yep. Here we go. All right, so that should be 0.25, right? Because the z-score of 0.25 gave me 0.5987. I wanted 0.6, but unfortunately I couldn't get close enough. Okay, so now I should also qualify that. That is for the standard normal distribution. Okay. All right, so there we go. We've got the answers for all of those. Make sure they're copied down if you hadn't done so already. And let's have a look at our next question. We've got to show the area of the normal distribution where the values are above the top 20% of the data. Okay, so best thing to do here is to draw a rough sketch of your normal distribution first. We do a nice neat one. So there it is. There's your normal distribution. Now, if we're looking at the top 25% or 20%, then that is going to be here, roughly. Okay, so we want this bit here. Okay, and you want to find the z-score, right? The z-score which corresponds to this, right? Now, don't forget, down the middle here, let's put a z-score of 0, isn't it? Z equals 0 at the mean. So we know that we're going to be looking for a positive z-score, all right? Positive z-score. Now, this little section here is 20%. Okay, which means that this section here, to the left of that will be 80%. All right, so the probability that z greater than some number m is equal to 0.2 is the same as, well, if we can work out the equivalent problem, we're going to consider the probability that less than that same number is 80% of the data. Okay, because the distribution table is all to do with less than, so we need to convert this to an equivalent less than problem. Okay, so if we go to the table and we're looking for a number in the table which is 0.8, so let's try that. Coming back to the table, and let's just have a look. Here we go, and we're looking for, well, if you look at 0.84 here, this is very, very close to 0.8. So this is in fact the closest we can get in the table. So the z-score which corresponds to that is 0.84. So let's go back to that. And so we're going to write down that the probability that z is less than, and we're going to put 0.84 is equal to 0.7995. Okay, so that means that the z-score, this number here, is equal to 0.84. Okay, so now we did want to get 0.8, we got 0.795. So I would say this is only your approximate answer, okay? So 20% of the data is above this number and 80% is below. So that's your answer for that one. So essentially, what you found there, think about it, we're talking about the 8th decile. So we could say the 8th decile is approximately, right, approximately 0.84. And again, we're going to qualify that for the standard normal distribution. Rightio. So let's have a look at the next one. All right, top 10% of the data. So if we draw a little sketch, there's our distribution there. Okay, so down the middle, we know that's got a z-score of 0 and divides it in half. So 50% of the data is on the right. Now, if you're looking at the top 10% of the data, so let's just say that's just here, for example, just that region there. Now, we know there's z equals 0. We want to find the z-score here, which corresponds to that number. Now, the probability, right, z greater than some number m, right, is equal to 10%, right? Well, that is equivalent to saying, let's find the number m such that this is true, right? Because if 10% of the data is above z, that means 90% is below. So we need to convert this to an equivalent less than question so we can use the table. So what we want to do now is we want to find the z-score, which corresponds to 0.9. So let's have a look. Now, if you go to all right, let's have a look. Can we find, here we go. So we've got 1.28. That's very close, isn't it? Very, very close. So 0.8997 is very close to 0.9, which is what we wanted. So 1.28 is our z-score that we're after. So we can say then that the probability that z is less than 1.28, right, is equal to 0.7995. Let's just double check there for a minute. It was, sorry, 0.8997. 0.8997. Yeah, 0.8997. Okay, now essentially this here is the 9th decile. So 9th decile is the 90th percentile. So we could say that the 9th decile is approximately 1.28 for the standard normal distribution. Now, if we want to update our little sketch here, I'll just put down z equals 1.28 here. There we go. So that's the z-score where 10% of the data is above. Okay. Right. Now, copy that down and we'll do one more question. This is a new one I've added, so this won't be on your notes. And what do we have here? We've got a university professor determines that no more than 80% of this year's history candidates should pass the final examination. Okay, so let's just draw a little sketch here. And There we go. All right, so no more than 80% can pass. So we know in the middle, you've got 50%, so that's here. So 80% would be, I don't know, somewhere around about there. So we know that here is z equals 0. Yep. Now, what do they tell you? So they tell you, so that means 20% here. No more than 80% of this year's history to pass a final examination. Okay. Now I think we're just going to run out of video time here, so I'm going to put up this solution in a minute because my recorder is going to stop in a minute. So let's just, I'll put this up in a minute. Okay, so